Choosing when to stop based on what you observe changes what you measure. Stopping when a process looks favorable selects favorable trajectories. The result is not a sample from the original process. It is a sample from a biased selection of that process. Optional stopping is a state transition. It modifies the distribution of outcomes that enter the record. A stopping time is a random variable that specifies when the process halts. The decision to stop at any moment can only depend on what has been observed up to that moment. It cannot depend on future values of the process. This is the adaptedness requirement. Stopping rules that depend on future states are not valid stopping times and break the structure entirely. The optional sampling theorem states that for a martingale and a valid stopping time, the expected value at stopping equals the initial value. But this requires conditions that are not always met. The stopping time must be bounded, or the process must be uniformly integrable, or the expected stopping time must be finite with bounded increments. Without these, the theorem fails. Consider stopping a fair martingale when it reaches a positive threshold. The process stops only when it is at a favorable value. All reported stopping values are at or above the threshold. The distribution at stopping is shifted upward from the fair distribution. The underlying process is fair. The bias came entirely from the stopping rule. Searching through data for a model that fits well is optional stopping in model space. You stop when you find a favorable result. The reported result comes from the distribution of the best model found, not from the distribution of all models evaluated. This distribution is shifted above the true distribution. The bias is the mathematical consequence of the stopping rule. The optional sampling theorem requires at least one of three conditions. The stopping time is bounded. The stopped process is uniformly integrable. The expected stopping time is finite with bounded increments. When all conditions fail, the expected value at stopping is unconstrained. It can differ from the initial value by any amount. Verifying conditions is not optional, it is the theorem.